I've got this 50 amp load center in my barn, and when it was just a barn and had a few lights in it, that was fine. But now I've got a 5-horse compressor that's 220 volts, and I've got a water heater that's 220 volts in my barn. I've got a 220 volt outlet. I'm fixing to put air conditioning in to air condition the loft that I've closed in. So I need a lot more than just these 6 spaces. So I'm going to replace this smaller box with a 100 amp service. It'll be like this size. It'll have over 20 spaces in it for outlets. So I'm going to show you how to do that today. First, I'm going to remove the cover from the old service so that we can see how the wires are coming in and going out. Now if you look at this service, we have the power coming from the main house coming in the bottom here, and that's this big fat cable, and these number 6 gauge wires coming in to this main breaker that's on the poles here. So I've got a 220 volt breaker for the input, and then for the outputs I have some single phase 20 amp breakers that are going to outlets and lights in the barn. And then for my my 220 volt compressor and water heater and all those items, I've just tapped off of the main bar on either end, and they don't have their own breakers. That's really not a good situation. They should each have their own breaker with the right amperage. So that's another thing I'm going to fix today, is when I take this box out, I'll have it come in a main breaker, and then I'll have an individual breaker for every circuit that's going out. So the very first thing that needs to be done is I need to remove the power from this circuit. I have a tester, and I make sure my tester works. So with the power still on, I'll just touch the terminals of the main breaker here. And I don't know if you can see it with the light, but this is this tester, the 220 volts lights up. So you can see that the power is on right now. So I'm going to go to the main house breaker and turn the power off. So here we are at the main house breaker, and I'll just have a look in here at my labels. There's the barn is on 13 and 15. I'll come over here. You can just barely see the numbers 13 and 15. And I'll just turn this breaker off. So now there should be no power going to the barn. So here's an up-close shot of our input from the house to the barn main breaker. We'll just go ahead and touch these 2 terminals again with the tester, and nothing lights up, so there's no power coming in to the barn now. So it's safe to take the box off, take all the wires out, and that's what I'll do now. To remove the cable clamps from the box, we're just going to loosen these nuts on the clamp there, like this. We can use a pair of pliers to get it started. Just kind of grab on there and get it started, and it doesn't take much. You just get it moving and then it'll come right off. So just loosen these guys, and they just come off like that. Okay, and then this clamp will just come right up the wire. Now after I've gotten the cable clamp loose, then I will go ahead and take the wires loose from the circuit, from the breaker. So this first breaker, I look back at my other breaker panel at these labels, and I just peeled the label off of circuit number 2, which is the one I'm going to remove, and I'll put this label on the cable so that I know how that it goes back. This is an important step unless you want to go and figure out all your circuits again. So just go ahead and somewhere on the cable nearby, not too close to the box, but somewhere, just go ahead and put that sticker on there. If you don't already have a label but it's just written on the box, go ahead and write it on a piece of masking tape or something with a Sharpie, and then just put it on the cable so you'll be able to find it later. So I'll just take loose one circuit at a time. So this is the bare ground wire for this cable right here. And this is the white neutral wire. Just pull those out like that. And then I have the hot black wire that's on the breaker. Now what I can do is just undo the screw at the bottom of the breaker. And this might be a good point to go ahead and check your electric and make sure it's still not hooked up. But I checked it earlier and across the input, and it's not there, so I'm confident. If you're not confident, you can check each one as you go. So now we've got one circuit loose. You can see the black, the hot wire, the white, the neutral wire, and the ground bare wire. We'll just straighten these out as well as we can. They're stiff single conductor wires. Get them straightened out and then just pull it out through the bottom of the box. And this one is tacked to the wall here, so we'll just kind of push it out of the way until we're ready for it later. Now this ring that we took off earlier off of the clamp, we can just temporarily place it on the wire so that we don't lose it. Or you can just put it in a can or something, but don't lose that ring. Don't leave it in here or it'll fall out. So we'll just continue around the box and take off each circuit one at a time. So now we've got everything loose except for the main feed coming in here, and that's coming in via a conduit. So the conduit we can't just pull out of the box, we have to lift the box off of the conduit. So what we'll do, there's just a couple of screws holding the box in here and here. We'll take those screws out and then we'll just we'll undo the clamp, undo the wires, and lift the box off of the conduit. Okay, so that was the easy part, getting rid of the old box. Now we need to fit the new box in here. The new box is quite a bit larger, and the locations inside the box may be different, so the wire lengths may be a problem. But the boxes come with no holes in them, basically. They have pre-punched holes, if you can see that, all in them in various sizes. These are for just normal small clamps, and then these are several sizes in the same place, so we can punch out whichever size we need. So I want to take out the plug in the bottom here that matches the size, the threads, and the conduit. The best way I know to do that is just to look at the old box and see how it was broken out, and just break it out the same way, break out that same size. So it looks like on the old box, the hole on the old box is about the size of the smallest hole on this box. So I'll just go ahead and I'll note that this little disc right here is attached right there at this little spot. I don't know if you can see it, but that's a solid spot there. So I want to hit it on the far side to get it to bend in like that. And then I can just bend it back and forth a couple times and it'll pop right out. And have a little slug here that I can throw away. And just holding it in the old box, I can see that that was the right size. So this should fit right on the conduit. To attach the new box to the wall, I just want to screw into the studs here on either side of the box. The box is almost as wide as the stud opening, so I'm going to screw it flush up against this stud on this side, and then I'll just run screws across the gap into the stud on the other side. This box doesn't have holes in it already, but it has spots where you can tap out a hole, just like the temporary lug that we just took out for the wire. So these little spots right here, you can just get a center punch and knock that out. Okay, to put the new box on, I've got these fairly large-headed self-tapping screws that'll just screw right into the stud through the hole. So I'll thread these wires up through the bottom hole that I just opened up, and then I'll screw the box to the wall. Okay, so fortunately this conduit is flexible. As you can see, it has to lean over a little bit because the old box, the center of the old box was more over in this direction right here. And so I'm just bending the conduit over to come into the hole on the new box. And now we'll bolt in the conduit with the nut that came with it, and then we can go ahead and start putting breakers in. To tighten up the nut on the conduit clamp, I just use a pair of pliers and grab onto these tabs and just turn it. There's probably a better way to do this that an electrician could share with you, but that's how I do it. So just a word about 220 volts versus 120 volts and what comes into your house. From the transformer to your house, you're going to get 220 volts, and it'll be 120 on one side, 120 that's 180 degrees out of phase on the other side. You have to look this up in Wikipedia if you want a full explanation. And you'll get a neutral line, which is basically ground, and then you'll get a bare copper ground line, which really is ground. So most of your appliances in the house run on 120, so they would go from one of these phases to neutral would be 120. If you need 220, like for your hot water heater or your dryer or something, then it goes from this phase to the other phase, which is 180 degrees out. So basically they add 120 plus 120 gives you 240 volts. And so these phases are hooked up to every other bar in your breaker panel. So if you just want one phase, you have a single phase breaker that just clamps onto one of these phases. If you want two phases, if you need 240 volts, then you get a double phase breaker, a double breaker, and it clamps across two of these circuits and gives you the two-phase breaker. So gives you 240 volts. So that's why some breakers are fat and some are skinny. The skinny ones are single phase, and the fat ones in general are two phases or 240 volts. So this is 120, this is 240. So to bring in the voltage to my panel, I'm going to get a 60 amp two-phase breaker and connect these wires to it. So this is my 60 amp breaker, and if you need to know what a breaker's value is, it's right on the switch. There it says 60 amps. So I'm going to bring 60 amps in here, and it has two lugs where I'll connect the red and the black wire, which are two different phases. To connect the breaker, we just stick the wire into the terminal lug here. I don't know if you can see that. Just stick the wire to that open space there. If there's not enough space, you may need to loosen the terminal. Stick it all the way in there, and then just tighten down the lug. Make sure you strip the wire to the right distance. I'm not stripping any wires today because I'm changing out a box that's already been done. So there it is with the breaker with both wires connected to it. Now this box has two sides to it. You can connect breakers on this side or on this side. So there'll be two breakers per line here, one on each side. So this one I can connect to either side. I think it'll be easiest to connect it to the left side just because I have plenty of wire and I don't want the wire to get too balled up. So this type of breaker has little clamps on the back. They're going to clamp on this bar, and then it has clamps on the front. They're going to clamp on these two bars, and they're like 90 degrees out from each other. You can't put it in wrong. You can't put it in backwards. It won't go in. But you clamp the back on first, and then it'll swivel into place and clamp down. So you have to push pretty hard. And there it is, clamped in place. So what we have now, we're going to bring in power to here, to these two buses here, and it's going to provide 120 to every one of these, or if you go across two of these, you'll get 240 because these two will add up. Now we have this white wire and this bare wire that we need to take care of as well. Those just go to the ground bars on the side here. The white and the bare wires get tied together at the box. You wouldn't want to tie them together at the plug, but you tie them together at the box to get the proper grounding. So you just poke the neutral into these holes. There's little holes here. You have to loosen the screw out. Poke it into the hole and then just tighten that screw down nice and tight. You do the same thing for the bare copper wire. Just poke it into that hole. You can see it's going all the way through, and then just tighten that down nice and tight. So at this point we've brought power to this load center, and we can turn it on if we want to, and then all this would be energized, but we don't really want to work on it with it turned on. So we'll go ahead and bring the rest of the wires in. We'll have to pop out the holes in the bottom and in the top for the various circuits to come in. We'll bring those in and hook those up. Then when we get them all hooked up, we'll power it on and test it. Once you've got all the circuits installed back into your new box, then it's time to put the lid on, or the faceplate on. The faceplate has a door on it, typically. This one does. And on the door is the labels for all the breakers. And so I went ahead and labeled those with my label maker. And I highly recommend this because later you're going to be wondering which ones to turn on and off. When you get this faceplate, it's going to have 2 blanks for the first 2 breakers, and then the rest are going to be filled in with a little pop-out panels. So I need to pop out all the panels to match where my breakers are on here. Once you've punched out all the holes, hopefully you were very careful not to punch out any holes that didn't need to be punched out. But once you've got them all punched out, you should be able to just place it over the breakers. And the breakers may be splayed out a little bit, so you may need to just wiggle it back and forth to get it to fit over them. But you can see that's fitting pretty good. And once you put it on there, then you've got your 4 attaching screws on the corners. So I'll put those 4 screws in. Once you've installed the panel, then you can test all of the circuits. If you haven't already, you can turn on the main breaker, and then you can turn on each breaker and just verify the operation of each item that's on these breakers. I can see the lights are on in here, so I know that I got the lights breakers right, and have things plugged in various places. So I'll just go around and check all the things, and then that's all there is to it. It's fairly simple to do and can be done in one day if you have all the parts. So thanks for watching.